Welcome everyone to the Terminology Services presentation. My name's Jim Steele. I'm from CSIRO in Australia. We make the Onto server terminology server product. I'm not really going to talk about that today. I'm going to talk about the standard Terminology Services API that's part of FHIR. And the way I'm structuring this presentation is kind of to walk you through based on use cases. So depending on what you're trying to do with FHIR, how you might want to use the Terminology Services API to do that. So just before I get started, can I get a bit of a gauge of where people are at with terminology? Who's already using Terminology Services in their projects? A few? Okay. Is anyone a Terminology Services implementer? Okay, good. Hi, Peter. There are some other terminology talks that should follow on from this talk really well, so hopefully this will give you a good start. And then once you get interested, and clearly people are interested, standing in the aisles, then there are some other talks later in the conference that you can go along to that teach you more about SNOMED, more using SNOMED with the Terminology Services API, using LOINC with the Terminology Services API, and then some more advanced things like doing analytics on terminology, on coded data, and also using the closure operation, which I won't get to today. Okay, so why are we interested in terminology? And clearly we are, still people coming in. Terminology is really the basis of shared meaning when we're exchanging FHIR resources. So the structure definitions and the resources that are defined in the FHIR spec and the profiles that we write, these set out the structure and the sort of skeleton of the things that we're exchanging, but the real meaning lives usually in the coded data fields that go along with those. So in a large integrated system, having a single reference point for all of that terminology data is a really valuable thing, because you can have a single port of call to go to say, is this particular condition a type of diabetes, or is this particular medication a statin, or things like that. And externalizing that is also a really good thing if you're able to do that. It's a single point where you can update your terminologies as they change over time, so that all of the different components of your health IT system is quite literally talking the same language. So some of the areas that terminology plays a part in FHIR, if you're doing data entry type interfaces, then the Terminology Services API can help you use terminology to allow clinicians or patients or whoever's providing the data to enter coded data right off the bat. It can help you with validation. So if you're receiving data from a third-party source, then the Terminology Services API can be used to validate that coded data to see whether the codes that you're receiving are actually appropriate for the fields in which you're receiving them. It can help you with display and understanding. So if you're looking at a new terminology to gauge whether it's appropriate for your use, or inspecting some of your data, then you can use the Terminology Services API to tell you information about how different codes relate to each other. It can help you with mapping. When you are receiving data from external sources, it's a very common thing to need to normalize that data or to map it across to some canonical form, and the Terminology Services API has operations for that. It can help you with analytics if you need to categorize data into different clusters. Then you can use terminology service operations to do that. And then often we need to author terminology resources as well. So particularly if you're writing profiles, then you need to define new value sets and sometimes even new code systems for use in your profiles. So FHIR terminology is useful for that. And finally, if you're implementing a FHIR server for storing patients or conditions or medications or whatever, then if you can use a terminology server in smart ways, then you can support much better features like search, where you're able to provide clients of your server with terminology-aware search, so that they can search not just for a medication with a certain code, but a medication whose code fits in a certain value set that you've defined, or a medication that sits somewhere in a hierarchy of the terminology that they're using for medication coding. So I'll cover some of these use cases today. Some of them will be covered in later talks during the conference. So the three resources I'm going to talk about today, first of all, code system resource. This is a normative resource as of FHIR R4. It's been locked down. There are a couple of new things in R4, particularly code system supplements that I won't really get into today, although if you do have questions about that, please come and ask me afterwards. So the code system resource, a code system is some sort of collection of codes that have some sort of coherent meaning. They might be authored by a single authority, or they deal with a certain topic. They can exist in a hierarchy. They have a bunch of metadata about them. URL and a version are the most important of those because that's how we identify a code system when we're using codes in FHIR. A code system can define different properties and filters, so extra information on the code that you can use to build up selections of those codes. And then, of course, a code, a display, and a definition. A value set is the second resource. This resource is also normative in FHIR R4. And a value set draws codes from one or more code systems according to either a list of codes that you want from that code system or a rule or a set of rules that determines which codes from that code system are actually included in the value set. And I'll talk a little bit about how you can combine those lists of codes and rules to build up a value set. And then in the following session, I'll have a bit of a demo of that as well. The third resource that I'll talk about in a little bit less detail, I think, today is the concept map resource. And concept map is how you define mappings between codes into value sets. So one-to-one relationships between a code in one value set and a code in the other, which has a certain relationship between them. And that's used for mapping codes, for example, for normalization. So I suspect I won't need to cover this in great depth, but the interactions that we can have with FHIR, obviously there are the scribed operations that create, read, update, delete, but particularly important for terminology services are the FHIR operations. So things like expand, lookup, translate that we'll deal with here. And there are different ways of calling these, either with get or post, depending on the operation. And they can be called either at the type level, so you can just call value set / $something, or you can call them at the instance level, where you provide the particular value set that you're interested in performing the operation on. If it's an idempotent operation, meaning it doesn't change any state on the server and returns the same thing with repeated invocation, then you can call it using an HTTP GET request, and this is a good thing because GET requests can be cached. There are some operations in the Terminology Services API, particularly closure, which are not idempotent but do change state on the server, so they have to be invoked with an HTTP POST request. Again, I won't get into closure today, but if you're interested in that, then there's a talk on Friday about it. So where do these codes appear in FHIR? They're in pretty much every resource, and they can appear in 3 different forms. So in some resources, you'll see just a code. So these are cases where the binding for that particular field in FHIR has been pinned down to a single code system, so you don't need to say what code system you're drawing from, you just need to provide the code. And this is typically for things like resource status, where you don't have to say that it's HL7 FHIR resource status draft, you just say draft, because implicitly by which field it's in, it knows which code system it's dealing with. The second type that you'll see is a coding. A coding has a system and a version and a code and a display and a user selected. The mandatory ones of those are system and code. So this is for cases where you might potentially have different code systems that are being used, and you need to clarify which one is being used by providing a system field. The other fields are optional. If you want to pin down to a version, you can. If you want to say what the display was when it was selected, then you can. And there are rules about validity of that I'll get to when I touch on the validate code operation. The third and probably most common type that you'll see is codable concept. So codable concept allows you to store any number of codings, so it should say 0 ... there. Plus, you can also define a text representation. The intent of codable concept is not that you put in multiple different concepts in there, so you shouldn't have a codable concept that says sort of torn ACL and reconstruction by hamstring graft, because those are different concepts. The intention, if you are putting multiple codings in a codable concept, is that they're different codes that mean the same thing. So you might have LOINC code for a certain pathology test and a SNOMED code for a certain pathology test, or an ICD code for a certain procedure or a certain condition and a SNOMED code for a certain condition. So these are for cases where you have different codes that mean essentially the same thing. So that's the intention within a codable concept. The other place where you see codes in FHIR is when you do search. So when you're searching on coded fields in FHIR, it'll be what FHIR calls a token-typed search parameter. So this can be represented using a system and then a pipe and then the code in the search parameter value. There's actually 4 forms of that. You can either provide the system and the code. You can just provide the code, or you can provide a pipe and then the code, which means it's a code where there's definitely no system. Or you can just provide the system and then the pipe, and that says any code so long as it's in that system. There are also a bunch of modifiers that you can put on token-type search parameters. So you can put text and not, which are defined on all parameters, and they're not that interesting from a terminology point of view. You can put code : below equals, and then put a code, and that will say match any resource where that field has that code or any of its descendants hierarchically in the code system. So that's below, or above is the inverse. So if you put code : above equals and then a certain code, it'll find that code or any of its ancestors. You can define in, you can use in or not in, and this refers to value sets. So this allows you to say something like condition in and then my chronic disease value set as a URL, and that should return you any resource where the code is in that certain value set. And then there's also of type, which is for identifiers and isn't particularly interesting for most resource types. Just by the way, if people have questions as I'm going along, please just put up your hand and ask them. I don't insist on waiting until the end. So the first use case I'm going to talk about is user interfaces for data entry. So this is obviously very common. And what we're looking to do in this case is, first of all, we need to identify which code systems we're interested in. Now, hopefully these are standardized code systems, but in a lot of cases it has to be proprietary code systems that you might be defining yourself. But once you've chosen the code systems that you need to support for data entry, then you need to define value sets. Sometimes that's a really simple value set, like all of the code system. Or sometimes it's going to be much more specific, where you want to narrow it down to a certain list of codes or some certain rules that determine which codes are acceptable in that context. If your value set is small, you might be using something like a pick list or even radio buttons, and you can retrieve that list of possible values using expand. More likely, if your value set is large, anything larger than even sort of 10, realistically you're going to want to support type ahead or some sort of interface like that. And if that's what you're doing, you can use expand with a text filter, and I'll show how that works. So this is then the first operation in the Terminology Services API, and probably the most interesting is the expand operation. So as I said, value sets can be defined either as a list of codes or as a set of rules that determine whether a code is in that value set. And the expand operation is what takes that logical definition of the value set and converts it into an actual list of all the codes that satisfy the rules. So when you do that, the result of the expand operation comes back as another value set which has the expansion element populated. So when you're defining the rules that determine the composition of the value set, then that goes in the compose element of the value set. And when you've expanded it, it'll be in the expansion element. So there are a bunch of parameters that can go into the expand operation. Is this a laser pointer as well?
Yeah, it is. If you press
the red button?
I think so.
Ooh, cool. Okay, so the most interesting parameter for expand is filter. So if you pass in a text filter, then it will limit the expansion that comes back to codes or concepts that match that filter in some way. Now that might be as simple as the code or the display text for the code matches that filter, or with certain terminologies or certain servers, then the server might be smart enough to look at all synonyms that are available for that concept, or perhaps even do smarter heuristic things such as misspelling correction or things like that. The other parameters that are interesting then, so filter is the parameter that you're likely to use if you're doing a type ahead widget. So you take the text that someone's already entered, you send off an expand request to the server, and the expansion comes back, is hopefully smaller each time that they type something in, and those are the terms that are matching and being presented to the user. The other parameters that are particularly interesting, so there's count and offset. This allows you to page through an expansion. So the first request you probably make is you might limit it to a count of, say, 10 and an offset of 0 because you're wanting the first page, but then you can get subsequent pages with subsequent calls to expand. There's also a whole bunch of parameters in here that allow you to control the shape of the value set that comes back. So if you use include designations, you can make sure that designations, which is usually synonyms, come back in the expansion. You can make sure that the original definition for the value set also comes back in the expansion. You can ask for only active terms, and then a whole bunch of others. Because we're in Europe with a whole bunch of languages, display language is really important as well. It allows you to specify the language of the display terms that come back. And it can also be used to invoke the use of code system supplements. So code system supplements isn't something I'll get into here, but again, if you have questions, come and ask me. It's a really powerful way of changing a code system that's been defined by someone else to do things like add translations in or add new synonyms in. So to call expand, it can be called at either the type or the instance level. So if you call it at the type level, there's a URL parameter that you can pass it to specify which value set you're interested in. If you call it the instance level, obviously it's on that value set. And you can do it either as a GET request or as a POST request. And if you do it as a POST request, you can post in the value set yourself. So this is really useful if you've got a sort of dynamic value set that's been constructed based on something the users entered earlier, perhaps, or even something that just changes with time. And you can just send the value set across to the server, say expand this, and it'll send it back to you. So the value set doesn't always have to be created on the server to expand it. So this is the main way that we can search for code in FHIR. So just as a couple of quick examples, this is an example using the administrative gender code system from the FHIR spec itself. So what I'm going to do here is I'm just going to send through a GET request to expand it. I'm going to give the URL of that value set, tell it that I want FHIR JSON coming back, and it'll come back with a value set which has this expansion element populated. It tells me the nature of the request that I sent in, and then it comes back with, in the contained section, it's got the list of codes, so the 4 codes that are in that code system in FHIR. So that's a simple one. A slightly more complicated one, in this case we're going to search a code system, in this case we're going to search LOINC. So http loinc.org/vs is the implicit code system, implicit value set for all of the codes in LOINC. And we're going to give it a filter, which is your analysis, and say we only want 10 back. And in this case, it'll come back, it'll tell us that the total for this value set expansion was 52, but that we actually only asked for sorry, I haven't updated this slide. It's actually count equals 3 here because we've passed in 3, and it comes back with the top 3 matches. Now, what the top 3 means depends on your terminology server. So some terminology servers will do their best to sort the results that come back according to how well they match the query that you sent through. Some might send it back just in alphabetical order. It depends on the server implementation as to what they do with that. So that's expand with a filter. Another way that you can invoke expand is using the context parameter. So in this case, what we might say is, I don't know what the value set URL is, but I'm looking for something that will fit in the medication.status field. In my medication results, there's a status field, and I want whatever goes in there. And in this case, the terminology server knows what the value set binding is for that, and it'll come back and say, oh, okay, yep, that's this medication status value set here, and here are the codes that come back for that. So you can use context instead of using URL if you're using it particularly to populate a field in a resource. Okay, so second use case that we're interested in, we're analysing and validating some sort of coded data that's coming into us, and we want to use terminology server to tell us whether the coded parts of that are valid for the fields that they've been provided in. The first thing we want to do there again is we want to identify the code systems and value sets that we're interested in for each of the fields. And then we can use the validate code operation to check whether the codes that we have are valid for that field. And if we've also received the display text for those codes, then we can check as well whether the display text that we've been provided with is an acceptable display text for that particular code. We might also want to do some other things. So if we're receiving external data, we probably need to do some normalization, and we can use the translate operation to do that. And we may want to do some sort of reasoning about the hierarchy of the codes as well, to try and map it into categories. So we might use subsumes or closure or validate code for that. So I'll get to those operations in a moment. But the next one I'll deal with is this validate code operation. So this takes essentially a couple of parameters. It takes a system and it takes a code, and it says yes or no, that is or isn't. And it takes a value set, and it tells you that system, that code in that system is either a member of that value set or it's not. If they provide a display text as well, then the operation will additionally tell you whether the display text is an acceptable display text for that code. So by way of examples, in this case I'm going to call validate code. I'm going to do it as a GET request. I'm going to validate it against this value set here using the URL parameter, and this is the implicit value set for all of the codes in SNOMED. So that's quite a lot. I'm going to pass in that the code I'm specifying has the system SNOMED, and the code is 383620002. And in this case, my server comes back with a parameters object. So this is what always comes back from a validate code. It says the result is true, saying this value set does contain this code. And it says, just for your information, the display text is dengue fever. Now the server doesn't have to provide that. That's an optional thing, but in this case, this server does provide the display text as well. Here's another example. This one's, again, using SNOMED. I'm going to pass in validate code. I'm going to give it, again, the all of SNOMED value set. Now, in most cases, I would stress you wouldn't be validating against all of SNOMED. For almost every use case where you've got a code coming in for a certain field, you're going to be interested in a small part of SNOMED, whether it's all clinical findings, which is small in the scope of 150,000 concepts or whatever it's up to, but it's very rarely going to be all of SNOMED. But for the sake of the example, I'm going to validate this against all of SNOMED, and I'm going to say the code is SNOMED code 136444009, and I'm going to say the display text I receive for that is hypercholesterolemia. And when I do that, the server's going to come back and it's going to say, nope, that's not acceptable. It's going to say the code exists in the value set, but the display hypercholesterolemia is incorrect. Yes?
How do you specify the language for the text?
I think there's a display language parameter for validate code as well. So it'll be the same as you would have for value set expand, you do for value set validate code. And like expand, if you do provide a language code that does invoke, or that can, depending on the server, that can invoke code system supplements as well.
So can you validate multiple codes in single code?
No, you can do that with a batch, but you can't do it with a single call to validate code. It's single code. On most servers I've seen, this operation is very quick though. So what I've found, certainly with our server, is that batch actually didn't bias that much because it was so quick in the server. We look at turnarounds of a few milliseconds for a validate code call. So the batch actually didn't save us anything just because of traffic. Yep.
The display check is syntax or semantic? Specifically, hypercholesterolemia is high cholesterol is also semantically equal?
So it's syntactic. It's syntax. So in this case, SNOMED defines a set of synonyms, or the SNOMED edition, which is being referred to here, defines a set of synonyms. And in this case, it was the Australian extension. And in the Australian extension, it needs to be AEMIA at the end. Yeah, it's completely lexical. Does this exactly match the synonyms that are defined for this code by the code system? That's right. So a third context that we can talk about, if we're exploring a set of codes and we just want to look at the relationships between them, then the operation that we can use to do that is probably the lookup operation. So lookup is an operation that allows you to just retrieve all the details about a code. And we can use the child and parent properties that come back from that, or we could use operations like subsumes or closure to sort of navigate the hierarchy that exists between the codes that we have, as opposed to the codes of the entire code system. So the lookup operation is fairly simple. The lookup operation allows us to pass in a code and a code system and to say, tell me what you know about this code. You can tell it specific properties that you're interested in as well. If you don't in the call define which properties you're interested in, then the server's on its own recognizance as to what properties it gives you back. So it might give you back all of the properties it knows about. It might give you back some set that it thinks are important. Here's an example. So this is a lookup on a code system that I've defined for the Australian jurisdictions. And I'm asking for what information is there about the code WA. And it comes back with a parameters object. It says the name of the code system is Australian jurisdictions. The version is this. The display of the code you've asked for is Western Australia. And it'll say, and I've got some designations for that. So there's a synonym. So this is the SNOMED code for synonym, which it's the use tells us what kind of designation this is. And it says that synonym is West Australia, is an acceptable synonym for that state. And it'll also say that it has a property which is the parent is AU state. So it can come back with those parent-child relationships as well. Another operation that we can use to sort of investigate the relationships between codes is the subsumes operation. So the subsumes operation allows us to pass in two codes and say, what, if any, subsumption relationship exists between these two codes? So we can pass in these code A and code B parameters, and we can either do that using a code and system pair, optionally with a version as well, or as a coding A and B. And the result will come back. It's a very simple result that just comes back and says they're equivalent. A subsumes B, A is subsumed by B, or there's no subsumption relationship between these two. This operation should depend on the hierarchy meaning of the code system. So when you define a code system, one of the properties you can set is what the hierarchy meaning is. So it could be an is a hierarchy, it could be a part of hierarchy, it could be a classified by hierarchy, or there could be no meaningful hierarchy. So in which case you should just ignore any nesting that appears when you define the code system. And the subsumes operation really should only work if it's a subsumption-based hierarchy. If we are looking at, I've got an example. So in this case, I'm going to say, invoke the subsumes operation. I'm going to pass in two of these SNOMED codes. I can't remember what they are at the moment. But when we run the operation, it gives us the parameters back and says the outcome is subsumes, which means that this 855.62004 subsumes 302.5.4.006. If we really want to get into exploring larger hierarchies that go beyond, and particularly well beyond, two codes, then an alternative way to do that is using the closure operation, which allows us to build up a transitive closure operation amongst a set of codes. And if you're interested in that, then Rob is doing a talk on Friday that will cover that. So the next use case I'm going to talk about is the mapping use case. So again, often we receive codes in one code system and we need to map them either across to another code system, or maybe we're trying to categorize codes, so we're mapping them up to some sort of category code. And we can do this using the concept map resource, and particularly using the translate operation. So the translate operation takes a concept map that is defined on the server, or maybe implicit on the server. There are some implicit concept maps that are defined for some code systems. And it will attempt to translate a code that you pass in, and it will return the code or codes that is mapped to by that concept map. So typically that means just looking up the concept map resource and looking at the code-to-code maps that are expressed in that concept resource, and just either returning the target, or if you're invoking translate with the reverse flag, then returning the source. But there are some implicit ones, or even algorithmic ones, depending on your server, that might not necessarily work that way. So when we do that, we pass in the code, the source code that we've got, as either a code and system pair or a coding or a codable concept. And then we tell it the value set, the source value set that we're interested in if we want, and the target value set, which we do need to know. And if we need, it can be run in reverse. Now, I should stress that running in reverse doesn't mean that it's a bidirectional map. Running in reverse does not mean what does this code map to. It means what other codes map to this code, which is a subtly different question, but that does make a difference when you talk to terminologists who've written maps. The result then comes back as a parameters object with match elements that tell you essentially what the correspondences are with codes in the concept map. Each of those have a relationship. So in FHIR R4, there are about, I think, 10 relationships that are defined. That is going to change in a subsequent release of FHIR. That will be greatly reduced, so it's a simpler set of relationships that are available to choose from. So at the moment, there's equal and equivalent, and there's narrower and specializers, and there's wider and generalizers, and there's unrelated. And so there's a large set, including a bunch that sound very similar and have only very subtly different meanings, depending who you talk to, and that will be greatly simplified in FHIR R5. So just as an example, in this case, what I'm going to use in this case is actually an implicit concept map. So in SNOMED, and Peter will perhaps cover this in his talk tomorrow, there are historical associations ref sets that say for a retired code, what code has this been replaced by, or what code is this equivalent to, so that you can migrate data forward if you need to do that. And these are exposed in FHIR as implicit concept maps. So what I'm doing here is I'm saying I want you to use this implicit concept map from SNOMED. It's probably the replaced by ref set. The target that I'm looking for is the set of all SNOMED codes, so the target should come from that. And the code I'm interested in you translating is a SNOMED code 399144008. And when I do that, I get a parameters object back. It says true, so there is a mapping for this code. And then it'll say in the match, it'll define each of the different maps for this. So in this case, it's found one. It'll say it's an equivalence relationship is equivalent. And here's the concept that it maps to. So the source, and the source tells us which map resulted in this particular mapping. So in this case, it tells us that it was this, it's flowed off the screen, but it's the implicit concept map for that historical association ref set. And it'll say the replacement code is diabetes mellitus co-current and due to hemochromatosis. So this is a replacement for bronze diabetes, which is not actually a diabetes, so it was retired from SNOMED. Yep.
Can you translate, what kind of translations can you do? Can you do amongst like one codable concept, like translate from value sets to value sets, or could you go from whatever SNOMED to ICD, for instance?
It's whatever you've defined the concept map as. So yes, you can do it. If you define a map from SNOMED to ICD, then you can do translate using that map.
And how many like existing maps are there today that we can use?
It depends on the server. And it depends on the context. So for example, my company has done a map from SNOMED codes to ICD-10 AM, which is the Australian extension, codes for the purposes of emergency room billing in Australian hospitals. And people, it's quite big, it's about 90,000 concepts. People ask us about it all the time, whether they can use it for something else, and we say no, because it's specific to that usage context. And even if when you reuse it, you get 95% reliability and fitness for purpose, there's going to be that 5% where some of those codes map to other codes because it's for this specific purpose. So there are lots of maps out there, but you should always be cautious about using them about whether they're fit for purpose. There is also a SNOMED to ICD-10 map in the SNOMED release, but it's different. It's not fully automatable because there are a bunch of rows in there where you need to look at the information model to really determine whether the map is appropriate. So it's not enough just to look at the code, the source code, and determine which target code. There's other contexts that you need to consider for that map as well. I haven't seen a sort of maturity scale for concept maps. It's something that you could certainly define in an extension. It's just through use, usually. Yeah. In terms of the predefined ones that are in the FHIR spec, the only ones that I know of are the four historical associations ref sets in SNOMED that are exposed as implicit concept maps. I don't think the FHIR spec mentions... there are other maps that are defined, I think, for mapping codes as part of FHIR 3 to 4 migration or 2 to 3 migration, probably. I should say too, concept map is not a normative resource yet. I think it's maturity 3. Yep. So other things that we might want to do with FHIR terminology. So we can do more advanced analytics with coded data. So if we want to do this, one of the first things we often do is we start building up value sets that correspond to the categories that we're interested in. So we're interested in grouping data into according to the codes that it contains. So we can build up some quite sophisticated value sets. So we could build up a value set for chronic disease or for COPD or for heart disease and sort of classify our data according to these value sets. And we can do that using validate code, which will tell us whether a given code is in these value sets that we've defined. Or if we're just doing it by hierarchy, we can use subsume. So if we just want to classify things based on which LOINC part hierarchy they're a part of, or which SNOMED hierarchy they're a part of, then we can use subsumes to do that. Or we can use closure if we just want to see a more complex relationship between them. And then hopefully we'll use a FHIR server with terminology support, because if we've been given a bunch of FHIR resources and there are codes in that, then we can use those terminology-aware search parameters like code below, code in, to try and do some of that filtering for us. So the other thing that we often need to do is author these terminology resources. Particularly if you're defining profiles, you're probably needing to define some proprietary or localized code systems. You're probably needing to define some value sets that correspond to the sets of codes that you want to allow in certain fields inside your profiled resources. So we need to define those value sets, and then you need to define the bindings for those value sets. And I'm sure the profiling session would have covered terminology bindings and the strength of those bindings through required, preferred, extensible, and example. So we can represent proprietary or local things as code system resources, and we can define concept maps for mapping between these. And I'll give a couple of quick examples. So this is a small example that I'll work through of a code system. So a code system starts with a whole bunch of metadata. So within FHIR, you typically identify a code system using a URL, and you can optionally provide a version. If you don't provide a version, it will depend on your server whether it's able to resolve a certain version or whether it throws up its hands and says, I'm confused, I don't know which one to use. It will depend on both the server and how well you've done versioning. There's a whole bunch of metadata about the code system, so name and title. Identifiers in R4, you can provide multiple identifiers for a code system, which is a change. Status, experimental, date, publisher, etc. These don't change the way the operations function. Some of these properties do change the way the operations function. So case sensitive tells you whether the codes that you define in that code system are case sensitive. Compositional tells you whether the code system has a compositional syntax, such as SNOMED's post-coordination syntax, or UCOM supports a compositional syntax. I think the language code system actually supports a compositional syntax officially. You can define the hierarchy meaning, so that's whether it's a subsumption-based hierarchy or classified by or part of, etc. You can specify the version needed. So this goes to what in the SNOMED world is called concept permanence. And this means, do you need to provide a version for this code system whenever you use it? Or can you rely, or does the code system give you certain guarantees about the persistence of codes from one version to the next? The content field is where you specify whether the code system defines the full list of codes, in which case the content has a value of complete, whether you've just got a sample of the codes, in which case you might have content equals fragment, or you can have, I'm only giving you the metadata for the code system, so content equals not present. The supplements field, this is how you define code system supplements. So a code system supplement is like a mix-in or an addition to an existing code system. So using this supplements field, you tell it which other code system it's adding to. And then it can tell you count, which is the total number of concepts in the code system. You can also define properties and filters on the code system. So these are properties that might be defined on the code system and whether they can be filtered, and if they can, what are the filter operators that are supported. So as an example, here's a small code system. This one's the list of Australian jurisdictions. So I'll give it an identifier. I'll give it a version. What else is interesting here? I can specify the value set parameter, and this tells me this is the URL for the set of all codes, all active codes in this code system. So you can define that in the code system itself. I'm going to say this code system has all of the codes, so it's complete. I can say that there's some properties on this code system. So there's a capital property, which is of type string, and there's a neighbor property, which is of type code. And then I can continue defining the concepts in this code system. So for each concept, I can define hierarchy, and I can either do that using nesting, the way that you can see that this JSON structure is nested here, or you can use the parent or child properties, and this allows you to do sort of polyhierarchy if you've got a polyhierarchical code system. You can define the display term for each code. You can define designations, which is also the way that you define language translations for each concept. And you can define properties, which are things that you can later filter on when you're assembling value sets. So in my code system, I've got this top-level code, which is Australia, the whole of Australia jurisdiction. I've got an Australian state, and then I've got Western Australia, which includes a synonym. I can say that its capital is Perth, its neighbours are NT and SA. And then I can go on and define all the other codes as well. So the next resource, and probably the final one I'll get to today, is value set. So value set has the same metadata as code system, pretty much. Again, the important ones are URL and version. And then the important part is this compose block. So this allows you to define what codes are in the code system using includes and excludes. You can either include or exclude the whole of a code system by just specifying this system property and nothing else. That'll say everything in the code system. You can provide a list of codes. You can provide a filter. So for example, here there's a filter that says the concept is a descendant of value state. Or you can have combinations of it. Oh, there's another one that I haven't included here. You can include another value set that's defined elsewhere by its URI. And then you can combine them. So if you combine these within a single include block, it will take the intersection of those things. And if you define them in multiple includes, it will take the union. So if I were to put in this filter and then another filter in the same include block, it would say things that match both of those filters. If I were to put them in separate include blocks, it would say things that either match the first one or match the second one would be included in the value set. And then there are excludes, and that's the order in which these are processed. So first you compute all includes, and then you compute the excludes and take them out. Yep.
How would you model an extensible binding using this, for example?
Well, an extensible, it doesn't really affect the value set. So when you define a binding as extensible, it says that this is the value set that I've been given, but I'm not going to limit you to that. So the value set itself doesn't change. It's just the interpretation of validity of a code that goes into that field changes. And then there's a concept map resource. If you're interested in the details of defining concept maps, come and talk to me or come along to the next session. I don't have time to get into that now. Finally, again, if you are implementing a server, please do consider how your server might potentially integrate with a terminology server to support terminology-aware search. It's a really powerful feature of FHIR that is not very widely implemented at the moment, and I think can really change the game for what clients can do in terms of terminology data when they're interacting with a FHIR resource server. Using things like condition code below, procedure code in, these sorts of search parameters. If you do that, there's a bunch of ways that you can do it. You can either just use the operations that I've described, expand, validate code, etc. Or you can build virtual tables in your database that hit a terminology server periodically to make sure that it's up to date, but just query the table normally for normal operations. Or you can do local caches of value set membership based on a certain set of value sets that you're interested in, or hybrids of these approaches. So there's a bunch of different ways of doing that. And if you are implementing a server, I'd encourage you to look at those. So a couple of things I haven't covered here, advertising for future sessions. If you're interested in how all of this works for SNOMED, then please come along to Peter's talk tomorrow. He'll cover that. If you're interested in how all this works for Loink, then please come along to Dan's talk, I think, is also on tomorrow. And if you're interested in closure, the closure operation, which is one of the really good ways of synchronizing code system knowledge between a terminology server and another FHIR server, then please come along to Rob's talk on Friday, I think. And if you're interested in how you might do analytics on data that contains coded data, then please come along to John's talk on Friday afternoon, where he'll get into that, including some demos. And just as some links at the end, if you'd like a terminology browser, please consider Shrimp. It's free, it's online. Snapper is an online authoring tool for some of these resources, and that's our product if you're interested in terminology servers. Okay. Is that time?
Yep.
Cool. Thank you very much.